All right, today we're going to be talking about polynomial functions and introducing some concepts that they have. So first thing we're going to do is we're going to evaluate polynomial functions, or in other words, function notation. We've done this already, but there's a reason we're going to do it for some of the things that we're going to be doing next week. You need to understand some of it again, so we're going to review. And then we're going to identify general shapes of graphs of polynomial functions, leading into graphing them tomorrow. So that talks about end behavior. All right, so first thing we're going to talk about is the degrees. Now, we talked about degrees last week, but we also want to talk about what a leading coefficient is. A leading coefficient is the number in front of the highest degree. So we talked about degrees. There's a degree for each term. We have 3 terms here, and the degree for the first one is the sum of all its exponents, so in this case just 3. This one's 2, and this one is 1. Now remember, the degree of the polynomial is the highest one of those, between 3, 2, and 1, so of course it's 3. So this is the term that we really like. This is the most important term. It is the leading term. It has a coefficient. A coefficient, again, is the number part. So we have 7 as the leading coefficient, and the degree is 3. This is all one variable. There's not going to be extra variables. We're going to get into a section of algebra here that we're only going to work with one variable at a time. So if it's not one variable, we're not going to want to deal with those. So this is degree 3 with a leading coefficient of 7. All right, this one has multiple variables, so we're not going to deal with those. So it's got an a and a b. All right, this one has all just x's, so that's fine. Now we're looking for the leading coefficient. So this one's degree 5, degree 2, degree 0, and this one's degree 6. 6 is the biggest, so that's the degree of the whole polynomial is 6, and the leading coefficient is -8, even though it's in the back, and it's not leading very well, but it is -8. So the degree is 6 and -8. So what about this one? 3 terms, 3, 2, and 1, so this 3 is the one we're looking at. Degree of 3, leading coefficient of 3. Yay. This one has an x and a y, so not a one variable. Bunch of terms here. 3, 6, 0, 2, and 7. Well, 7's the biggest, so look at the coefficient for that is -5, so 7 with -5. All right, so function notation. We've done this already before, so let's look through b of 2. So remember what b of 2 means is we're going to take this formula and we're going to put 2 in for all the m's. So 2 and parentheses 2 squared plus 2 minus 1. And then we have to do order of operations. So exponents is going to come first, so that's going to make it 4. This parenthesis is just kind of extra. We don't need it, so I dropped it. Then we're going to multiply and get 8, and then do all the adding and subtracting and get 9 as an answer. Over here, we can do b of -3, so we can put -3 in there. So -3 squared is 9. Multiply those together for 18, subtract them all, and we get 14. We can also do it when we have variables here. So g of x plus 1. So I'm going to put the x plus 1 in there, which means it's x plus 1 times x plus 1, that's squared. And so you have to FOIL this out or Punnett square it. I did not write those out here. At this point, we should be able to do that. So we had x squared plus 2x plus 1, then the plus 3. Some like terms we can put together, so 2x squared plus 2x plus 4. Down here we have 2 on the outside g of x, so we just take what it is, put the x in instead of the b, and we're going to multiply everything by 2. So it's 2x squared plus 6. Just distribute it. So we can do things with just x's, or we can do the number parts here. Both are things that we should be able to do at this point. All right, let's talk about end behavior. All right, we have 4 different areas here, and this kind of looks like a lot and a lot of jumbo math terms and things like that. Let me kind of go through this with you. We are going to be talking about 2 different types of degrees. We can talk about the even degrees and the odd degrees. Even degrees would be obviously something that's degree of 2, degree of 4, degree of 6 and 8, so on and so forth. The odd degrees are x cubed, x to the 5th, x to the 7th, all the odd ones. And they act very differently. Now, a leading coefficient, that's why the leading coefficient is important, because it tells us which way the graph goes. So if it were even, we have this kind of a U-shaped graph. Leading coefficient is positive, it means that U is up. When it's negative, it means the U is going down. We'll talk about what end behavior is in just a minute in these symbols here. So when we're talking about odd kind of go in opposite ways. So this is a U-shaped or an upside down U. The odd ones go opposite, so one's down and one's up, or one's up and one's down. When it's positive, it's like a positive slope. If we drew a straight line, a positive slope here, that would be a positive slope. This would be a negative slope if we were drawing from the two arrow tips. So that's why when the leading coefficient is negative, it looks like this. But when it's odd, one side's going to be up and one side's going to be down. Depending upon the coefficient is what side is which. All right, before I talk about this end behavior, I want to go to the next couple slides and I'll come back to this. So just bear with me for this in just a moment. All right, what do we need by evens and odds? Well, odd functions will always have an odd number of zeros. Even will always have an even number. Actually, they'll be the degree. So an odd number, if it's degree of 5, there'll be 5 zeros. If there's an even number, they'll have, if it's degree 4, there'll be 4 zeros. And we're going to talk about a lot of that next week. All right. So I have some symbology here that I want to go over first before I go back and show you what those different things mean. So when I have x approaching positive infinity, that's how this is read, x approaching positive infinity. What that means is what happens to the graph on the right side when x is positive. So if I have a graph, we're talking about this side of the graph, the right side of the graph. When I say x is approaching negative infinity, that's what happens on the left side. And you can tell me what happens by these two symbols. So I'm going to ask these questions, and you're going to tell me the answer in these two symbols. F of x is going to positive infinity. That means the graph is going up. Or f of x is going to negative infinity, which means the graph is going down. So all you're basically telling me is on the right side, is it going up or down? On the left side, is it up or down? It is just a very weird set of symbols. Now, even degree, again, are U-shaped or upside down U-shaped, where both ends either go up or they go down. The odd degree is one up and one down. And remember, zeros are where the graph crosses the x-axis. All right, so let's go back. So look at this. If I say x is approaching negative infinity, so I'm looking at that means left side of the graph. What's happening to my graph? It's going up. And that's the symbology for going up. What about when x goes to negative infinity? Yes, it's kind of backwards. I understand that. That I'm asking the bottom part, but how it's worded, that's how it is. So as x goes to negative infinity, I'm asking what's happening on the right side. And you're going to tell me that the graph is going up. If you look down here, what's happening as I go to the left side? Well, the graph is going down. So I go to this side, the right side, the positive infinity, the graph is also going down. So see how that's symbology. Now, when it's even, notice that they are both the same. The positive infinity, negative infinity, negative infinity. I'm asking the x parts. You're telling me the f of x parts. All right. So over here, I'm going to ask x to negative infinity. So as it goes to the left side, what's happening? The graph is going down. So we have to state how it goes down. So negative infinity. As I go to positive infinity, it's going positive. And so you can see these other ones here. But that's the symbology we're going to have to go ahead and use when we go ahead and do these types of problems. All right. And again, that's what they are here. So you can go ahead and pause the slide for a moment if you need to write those down. All right, let's do a problem. All right, so we want to describe the end behavior. We wanted to tell me if it's even or odd, and we want to state the number of real zeros. Okay. So first and foremost, let's deal with this part because this is the easiest. Is it even or odd? Even, both the endpoints go in the same direction. They're both going down. So this is most assuredly an even degree. State the number of zeros. How many times does it cross the x-axis? None. So we have 0 of them. All right. Now let's talk about the end behavior. As I go to the left, this is going down, so I need to have a negative infinity. As I go to the right, this is going down, so that's a negative infinity. So let me show you the way that this answers. So this is as x goes to the positive side. So when I go to the right side here, what's happening? I'm going down, so negative infinity. As I go to the left side, what's happening? I'm also going down. And since those two match up, we are most assuredly even because they're matching up. Odds, remember, are going to be opposite. And it does not cross the x-axis, so it has no real zeros. All right, let's try this one. Let's talk about the end behavior. As x goes to positive, so we're talking about the right side, what's happening to this? It's going up, so we write a positive infinity. So I'm asking this part, you're telling me this part. So as x goes to negative infinity, what's happening? You're saying it goes to negative infinity, it's going down. So that's the symbology that you got to use. Now these two are opposite, and since they're opposite, that's an odd. And how many real zeros does it have? It only crosses once. All right, this one, they're both going up. This is most assuredly even. And how many zeros does it have? It crosses twice, so even with 2 zeros. This one up, one down, is odd. Crosses 1, 2, 3 times. Odd with 3 real zeros. And that's what I have for you today.